Hello, and welcome to my presentation on the microbiome and how it influences our physical and our mental health. What is our microbiome? Our body comprises many viruses, bacteria, and fungi that are known as collectively as the microbiome. These microbes live on the surface of our skin and in our intestines. The most significant number of these microbes are located in the section of our large intestine called the cecum. Of all these microbes, bacteria appear to be the most numerous and most researched. Latest studies show that the number of bacteria equals the number of cells in our body and weigh approximately 200 grams. Each individual's microbiome is unique, with no two individuals sharing the same microbiota, not even identical twins. The microbiome has co-evolved with our bodies through natural selection over millions of years. It impacts diverse physical processes such as fat storage, energy metabolism, blood pressure control, insulin and glucose metabolism, blood clotting and healing, to name but a few. Quite possibly the most crucial role it plays is in managing our immune system. Our gut microbiome communicates with immune cells in some ways and thus controls how our body responds to infection. Our immunity is also strongly affected by our emotions, with our microbiome playing a significant role in transmitting information about our environment that impacts our immune system. Our microbiome may have a close and influential role in our mental and emotional health. Research shows that the gut microbiome may well affect our central nervous system to control vital brain functions more than we have previously thought. The gut and the brain relationship is known as the gut-brain axis, or GBA. The gut microbiome may use neurotransmitters, chemicals produced in the brain by certain bacteria, to send messages to and from the brain. Because the gut is connected to the brain by millions of nerves, the microbiota may also use other means, such as the endocrine and immune pathways, to control messages sent through the central nervous system, CNS, to influence brain function and behavior. A disturbance to the gut-brain axis has been linked to several diseases, both physical and mental. Studies have shown that individuals with psychological and mental health disorders have different microbes in their guts compared to healthy individuals. In a study on the link between bacteria and depression, researchers discovered evidence that depletion of two bacteria, Coprococcus and Dialister, was common in patients with treatment-resistant major depressive disorder. The same study also identified higher levels of two bacteria, Faecalibacterium and Coprococcus, in individuals who recorded higher quality of life than usual. Both of these bacteria produce a short-chain fatty acid, butyrate. Butyrate possesses anti-inflammatory properties, enhances intestinal barrier function and mucosal immunity, and has a beneficial effect on intestinal homeostasis and energy metabolism. The bidirectional crosstalk between the central nervous system, the enteric system, and the gastrointestinal system is of significant importance to our physical and our mental health. At times of increased stress, our intestinal lining of the gut becomes permeable, allowing bacteria access to our immune system and enteric nervous system. Disturbances in the gut microbiome have resulted in health disorders such as irritable bowel disorder, obesity, Parkinson's disease, and Alzheimer's disease. This could be good news for certain sufferers, as increasing our understanding of the mechanisms underlying the microbiota, GBA, may allow us to use microbial-based interventions as successful therapeutic strategies for mental and physical ailments. So what dietary factors influence the gut? What we eat influences what microbes live in our digestive system. If we eat a plant-based diet, we will have a very different microbiome from someone raised on a highly processed animal-based diet. Eating a diverse range of plant-based foods can lead to a more diverse microbiome and a more resilient immune system. Following some studies on vegan diets, It was seen that improving our diet to one high or exclusively in plants may also reduce mental ailments like depression, metabolic diseases, and cardiovascular diseases such as hypertension. Studies comparing the Mediterranean diet with the vegan diet showed that the vegan diet conferred more significant benefits on the host microbiome. Improvements in the microbiome are most likely due to the higher ratio of plant-based foods rich in fiber, phytonutrients, and flavonoids. Eat whole plants, legumes, a variety of fruits, and plenty of whole grains, which are rich in fiber and beneficial carbs such as beta-glucan. The Western diet, which is high in animal products and fat, but low in whole plants, have contributed to poor intestinal health and other degenerative disorders, such as metabolic disorder. Animal products are low in fiber and high in cholesterol and saturated fats, which negatively affect the microbiome. Animal fats also increase permeability of intestinal epithelium and thus contribute to the breakdown of the intestinal barrier. Research on mice has revealed changes in the gut microbiome, resulting in endotoxemia-induced inflammation. So comparative studies on rural Africans and African Americans have shown that not just the excess of choline and cholesterol in a meat-rich diet causes problems. The lack of microbial diversity may also be a significant factor. Widespread clinical use of antibiotics and antibiotics in raising livestock has had many adverse effects on the human gastrointestinal tract. Understanding the adverse effects on our gut is an argument for reducing or eliminating the consumption of animal products. Processed foods are low in fiber and lack the prebiotics that nourish the microbiome. Many also contain additives such as aspartame, which stimulates the growth of opportunistic Enterobacteria in the gut. According to a study on maternal metabolism, consumption of low-calorie sweeteners can alter gut microbiota consumption and impair glucose tolerance and learning performance. A diet high in sugary products can promote the growth of unhealthy bacteria in the gut, leading to obesity, metabolic disorder, and other degenerative diseases. Researchers are examining the role that fermented foods play in fostering neurological health in animals and are hopeful that these may provide possible therapies for mental health in humans. Current research examines the role that fermented foods play in helping to strengthen the intestinal barrier and thus reduce inflammation, which may irritate the brain and reduce functionality and mental health. While there are no clinical studies to show that the benefits of microbial fermentation in food can help with depression and anxiety, there is other evidence that many of these foods are rich in nutrients, which are such as fermentable fibers and prebiotics that enrich our microbiota and help our bodies to stay healthy. Indeed, according to some studies, fermented foods may also survive digestion and live in our gastrointestinal tract as a transient microbiome. Some possible foods to include in the diet are tempeh, plant-based yogurts, sauerkraut, kombucha, and kefir. Plant-based diets, such as Mediterranean or even better, the vegan diet, contain high levels of polyphenols. Polyphenols are plant compounds that promote a healthy gut microbiome by stimulating the development of beneficial bacteria that possess anti-inflammatory and antioxidant properties. Fermented foods contain polyphenols. Fermented foods like green tea, dark chocolate, red wine, whole grains, turmeric, berries, and olives. What lifestyle factors influence the gut? Studies have shown that the microbiota in individuals varies according to genetics and environment, with the most crucial development happening in the first 3 years of life. The first 1,000 days of an infant's life may profoundly impact their whole life's health status. Studies have shown that infants born by cesarean do not have the identical microbiome makeup as their mothers and show less diversity than infants born vaginally. Our declining breastfeeding rates may also cause a loss of microbial diversity, as maternal milk is an integral part of developing a healthy microbiome. Bifidobacteria are bacteria that grow in the infant's intestine in the first few months after birth. These bacteria aid digestion of healthy oligosaccharides in breast milk. We can recognize the potential ramifications of this loss of diversity when comparing the differences when examining children raised in rural Africa with greater diversity in the microbiome and more resilient strains than children from Europe. Natural birth and breastfeed confers lifelong benefits to the individual and the microbiome. The use of antibiotics affects the gastrointestinal flora. We are only just beginning to understand the possible long-term effects of antibiotic exposure on the microbiota. Antibiotics are well known to disrupt the gut microbiota, and recovery depends on many factors, including the diet, community of the host, and the reservoirs of bacteria in the host body. While antibiotics may be necessary for certain circumstances, studies show that antibiotic exposure, particularly during pregnancy, may have adverse effects on the immune system of infants because it may alter the mother's microbiota. Individuals who live on farms have very different microbiomes from those in cities. Additionally, individuals born and raised in one country have very different microbiomes to those in their host country. Scientists speculate that the rise in many diseases and our susceptibility to them, such as COVID-19, is commensurate with our loss of bacterial diversity. Our obsession with living in overly hygienic conditions may play a detrimental role. Children's immune system development and tolerance are dependent on the diversity of the commensal gut flora. Children need to be exposed to immunogenic material to build up the richness of the gut microbiota and develop a functional immune system. A lack of diversity may cause sensitivity to allergens. Early and repeated use of antimicrobial products may also increase the risk of obesity, inflammatory, and allergic diseases later. This may play a significant role in developing tolerance to foreign proteins. Chronic emotional and mental stress has adverse consequences for the body and the microbiome. Our body's major systems respond to stress, fight, flight, to protect us. When stress becomes chronic and unremitting, these chemicals can cause biochemical changes in the microbiota and other major systems in the body. When faced with sudden or chronic stress, it is not uncommon to experience indigestion, vomiting and nausea, constipation and diarrhea, and heartburn and abdominal pain. According to medicine, stress and depression can change gut bacteria composition by releasing stress hormones that cause inflammation and autonomic alterations. Learning how to manage stress through meditation, breath work, taking time for leisure activities, developing positive self-talk, yoga, and exercise will help to improve the microbiome. Healthy exercise and sufficient sleep are essential to developing and to maintain a healthy microbiome. Circadian disruption and sleep deprivation can negatively affect the gut microbiome, resulting in dysbiosis, a bacterial imbalance affecting the gut. Lack of exercise may exacerbate many chronic degenerative diseases. However, daily regular exercise does help to improve mood and relaxes and tones muscles and assists in maintaining a healthy body weight. Along with regular restorative sleep, the maintenance of normal body weight and the positive emotional benefits of exercise play a role in maintaining microbiome integrity. The connections between our gut microbiota and its role in energy homeostasis and reduction of inflammation are becoming more and more evident every day. Adopting a healthy lifestyle, reducing antibiotics to a minimum, encouraging breastfeeding, and avoiding excessive dietary fat promotes a healthy weight and a healthy gut microbiome that can protect us from many degenerative and inflammatory diseases. Thank you very much for joining my presentation. I hope that you have enjoyed it.